whatever your denominator is being pulled out and being written as the root. Okay? And then your a stays there. All right, so I like to circle the denominator and move it out front like that so that I can remember what goes on. So if it's on the bottom, it's going to come out to be the root. So again, a rational expression is an expression that has a fraction as an exponent. So we're going to work today on translating between the two. Okay? So it says the denominator becomes the root, which is what we said here, right? The denominator came out to be the root. The numerator stays as the power. All right, so let's look at some of these examples here. It says write each expression in radical form. So the first thing I'm going to do, I'm changing it to radical form, which means I need a square root in the answer. So if we look at number 1, the 5 is in the denominator, right? So the 5 is going to come out to be the what? What's that word? The root, okay? So then it's going to be the 5th root, please make your 5 little, of 6, and then what's the numerator, or what's the power going to be? Just 1. Now, do you have to write 1 there? It means the same thing when you don't, right? When it's a 1, it means the same thing. Okay, that's all. Okay, so number 2, we know that we have something now in parentheses. So if it's in parentheses, you need to make sure that you keep it in parentheses, okay? So the 3 is going to come out, right? And that's going to become the root. And then we're going to put 4x underneath here to the first power. Now, if I don't put parentheses, what is being raised to the first power? Just the x, right? But if I put parentheses, now what is being raised to the first power? The 4 and the x, which is how it should be. Okay? So when you see parentheses in the problem, you should put it in your answer. All right? Why don't you try number 3 on your own and see if you can do it? All right, what did you get on this one? Who wants to give me their answer? Aspen?
Root of 5.
Okay, so you're correct to say the 5th root.
Oh, okay, the 5th root.
Okay.
In parentheses 5c, and parentheses and the squared.
Good. Anybody else agree with that? The 5th root of 5c all squared? Yeah. Good. Okay, so not very hard, right? So on 4 through 6, we're going the opposite direction. Okay, so we're going to take it out of the radical and we're going to put it into a rational exponent. So 26 is my number here. I know that 4 is going to come out to be my denominator. What number is right here with the 26 that's the numerator? A 1. So this is going to be 26 to the 1/4. Okay. Number 5. We have this whole thing underneath here. We're going to go ahead and put this whole thing in parentheses because that's a big thing to take care of, right? So I have 6x to the 5th, y to the 7th, and I'm going to put that in parentheses. What number is my denominator here? 3. So then what do I want as my numerator? That one's kind of tricky, right? Because really, I have a 1 right out here, right? I have a 1 here. It's this whole thing. Even though there are some exponents in here, the whole thing is being raised to the first power. So I would put a 1 as my numerator. Why don't you try number... Yeah, Aston?
With these ones, like, if they have exponents with, like, the y or the x, you just have the 1 in the fraction since there's nothing that's being raised there.
Right.
You see it.
Yeah, so you kind of ignore what's in the exponents already and take out what the whole thing is being raised to. Okay? Try number 6 on your own, please. Check with your neighbor when you get finished. Okay, who wants to offer their answer? Ashley? X squared.
Y
Raised to the 1/3. Is that what you said?
Yeah.
Anybody else agree with that? Raised to the 1/3. Okay, any questions about this part so far?
So if there's what would you call that?
Variable?
A variable with the number, does it automatically go in parentheses?
Yeah, I would always put in parentheses. If there's a variable, I would always do parentheses. Yep. Because like if you look at example 2, right? If we took off the parentheses, then x is the only thing being raised to the 1. And it's the whole 4x being raised. Okay? All right. Second part. Now that we know how to do this, they're going to ask us to evaluate, which means to simplify it even more. Okay? So you're going to want to write kind of small in between the lines. It says, when evaluating rational expressions, first change it to radical form. Okay, so radical form 125 to the 1/3 power. That means we're going to take 3 and make it a what? A root. That's the word there. A root. So this becomes the cube root of 125. Okay, write that down. The cube root of 125. Now, we could write 125 to the first power, but it's still just 125. What this cube means is I need a group of 3 things. When we were simplifying square roots, we were looking for a group of 2 things, right? We were looking for a pair. So the number of the root tells you how many need to be in a group. So let's go ahead and break 125 apart. What makes 125? 5 and you're a little bit ahead. 5 and 25 make 125, right? And then what makes 25? 5 and 5. Remember, we needed a group of 3 things. Do we have a group of 3 things here? Okay. So I have 3 5s. For every group, you only write it one time, right? When we had our pairs, when it was square root, we only wrote it one time. So when you have a group of something, you only write it one time. So 125 raised to the 1/3 power is just 5. Because you had one group of 5s. That was it.
Now, what if you had one group of 5?
So we're going to do something like that. It's a good question. We're going to do something like that. Okay, let's look at number 8. 27x to the 2/3. So when you have a problem with a variable and a coefficient, we're going to kind of distribute it if you want to think of it like that. So I'm going to do 27 to the 2/3 power. And then I'm going to draw a line here. And I'm going to do x raised to the 2/3 power. Because the processes are done a little bit different. So split the coefficient and split the variable for right now. And then we'll bring them back together. So 27 to the 2/3. If I change that to radical form, what number becomes my root, Olivia? 3, right? The 3 is going to come out in front. So that means I have the cube root of 27 what? That means I have 2 27s, doesn't it? And I'm going to write them out. Instead of just 27 squared, I'm going to write 27 times 27.
Where does the cube or the square come in?
Because it's the numerator. Do you see it's the numerator?
Yeah.
So that means I have 27 squared. Okay, so I'm going to write it twice instead of just writing 27 squared. What are we looking for a group of? How many things? Group of 3 things, right? So let's just break down one of the 27s. What makes 27? 3 and 9. What makes 9? 3 and 3. So I have a group of 3 things, right? That's just one of the 27s. What's going to happen over here to this other 27? The same thing, right? 3 and 9, 3 and 3. So I have another group of 3s. So when you have more than one group, you're going to pull out more than one 3, right? How many 3s are you actually going to write? How many groups do you have? 2. So you're going to write 3
Squared.
Yep, 3 squared or 3 times 3. Okay, and then we still have our variable. Can we reduce x to the 2/3? Can that go anywhere? It can't. So this is just 3 times 3x to the 2/3. Well, what is 3 times 3?
9.
So this becomes 9x to the 2/3. Okay, we're going to do another one.
So you want to put that, you want to put the x and the 2/3 into,
Parentheses.
yeah.
So is the 9 being raised to the 2/3 or just the x? Did you say huh?
No, I was saying like down here, where you read it, you put 2 columns.
Yes.
You wouldn't make that 3 cubed x squared? Like, you get what?
No. So for the variable, you'll just leave the variable as is. The variable has a different process than the coefficient. And we'll do another one and you'll see what I'm talking about, okay? So let's look at number 9. This one has no variable. What is the root here? Mitchell, what's the root?
4.
4, right? The 4 is going to come out. So I have the 4th root. I'm going to write mine off to the side. I have the 4th root of 81 to the 1st power, but I'm just going to write 81. This means I'm looking for a group of how many things? 4 things. Okay, so what makes 81? 9 and 9. And then what makes 9? 3 and 3. 3 and 3. And what are you noticing?
4 things.
I have a group of 4 things, but I only have one group, so I only write it how many times? 1 time. So 81 raised to the 1/4 power is just 3. Questions so far? Okay, let's try number 10 like we did number 8. So we're going to split it apart. We're going to do just the coefficient first, and then we're going to worry about the variable. Okay, so I have 81 to the 3/2, and then I have n squared to the 3/2. So I'm going to kind of think about it as distributing. So I have 81 to the 3/2. Then I'm going to draw my line and split it. And I'm going to put n squared in parentheses since I have another exponent to take care of. Everyone okay with where that came from? Okay, so let's take care of 81. What number becomes my root, Ben? Or the 81, what becomes the root? 3 or 2? Which number is in the denominator? 2. So I'm going to have 2 go out front. So I'm looking for the second root or the square root. And how many 81s do I have left in there, Jonathan? How many 81s are left?
Well, once you pull out 2, you got 81 to the 3rd power.
81 to the 3rd. So I have 3 81s in there, right? So I'm going to put 81 times 81 times 81. And we're looking for a group of how many things?
3. No.
What's 2 things, right? That's what the root is 2. Now, we can break 81 down, but do you already have a group of 2 things?
Yeah.
Do you already have 2 81s that you could circle together?
Yeah.
Okay. So these 2 81s are going to go together. There's one group. Now I don't have any other groups yet, so I'm going to break this last 81 down. What does 81 break down to? 9 and 9, and is that a group there?
Yeah.
Okay. Not 3 and 3, 9 and 9. That's a group, right? So for every group that you circle, you write it how many times? Once. So I circled an 81, and I circled a 9. So I'm going to multiply those 2 numbers together. So someone do that on your calculator. What is 81 times 9?
729.
729. So my big number is 729. Now I have to deal with my variable. I have n squared times 3/2. Remember we multiply our exponents when they look like this? So I really have 2 over 1 times 3 over 2. I'm multiplying fractions. 2 over 1 times 3 over 2. Did you say what? Oh, okay. So 2 times 3 straight across is 6. 1 times 2 is 2. 6 divided by 2 is
3.
3. So this really becomes n to the third power. So we multiplied our exponents. Right. N to the third power. Okay. Questions on number 10? Let's look at number 11. So I'm doing the same thing. I am kind of distributing the 1/2. So I have 36 to the 1/2. I'm going to split the problem. Then I have x to the 6th to the 1/2. So let's take care of 36. What is the root, Taylor?
The root of 36?
Yeah, what comes out to be the root?
That's the 2.
The 2, right? Okay, so we have the square root of 36 to the first power, right? So I just have one of them. Now, we can break it down, but what is the square root of 36? 6, right? You could break it down into 6 and 6 and see your pair here. Okay. So I know it's going to be 6. Then if we go over to our variable, I have 6 over 1 times 1/2. Right, so I multiply my exponents. 6 over 2 is 3. So this becomes x to the third power. And it goes up there with the 6. Any questions on 11? Try 12 on your own, please. Take it a step at a time. How many 49s do you have left here? What's this number? So it's 49 to the third. So you have 3 49s. Notice whatever this top number is, 3, that means I had 3 81s down there. You didn't write that down. This one said you had 2 of them, so we put 2. So I have 3 49s. Right, so I have a group of 49 that gets circled together, and then 49 gets broken down to 7 and 7. So that means I have 49 times, not times 49, just 49 times 7, right? I have a group of 49s and a group of 7. So what is 49 times 7, Leanna? 343. Raise your hand if you have 343 as your number, your coefficient. Good. Okay, and then I go over to my variable, and I have 6 over 1 times 3 over 2. 18 over 2 is 9, so I should have x to the 9th. Who has 343 x to the 9th? Okay, if you did not get that, do you have any questions for me? No?
You would just reduce it down, right?
The 18 over 9? Yep, or 18 over 2. Yeah, 18 divided by 2 is 9. Okay, your homework for this after the test is to do homework 23. Some of them are multiple choice, but you need to make sure that you show your work. Do not forget parentheses. Okay? Now, take a look at homework 23 for a second. Notice that the first section is just rewriting it. You don't have to do what we just did, the solving, until you get to 21. The last 4 problems are the ones where you're doing that big long thing. Okay? So 1 through 20 is just rewriting. All right? Okay.